Hey there, folks. So, in this episode, I want to start work on, well, not episode, the next few episodes in this series. I want to start work on the AI and start getting some things in place there because we've got some basics. We've got things like trees, we've got buildings, we've got harvestable actors. Yes, our player character doesn't have any way to attack yet. Reason being there is I'm still digging into animations, but I want to start work on the next thing. That's going to be our AI. Now, with that, there is a few things we need to set up to get things started. We need to go through and get our code set up to be able to work with our AI behavior tree and behavior tree tasks and things like that, because those are going to be done in C++. So there is some work to do there. Now, one thing that is very important with working on this sort of thing is you need to make sure you have the right modules installed, or enabled, I should say, not installed. And within your project, every project has a build project name.build.cs, and that is right here where you within this, it defines the dependency modules that are added in. I'm actually going to clean this up so it's visually easier to look at. Now in here, I have actually gone through and I've actually already added in the Niagara module because that wasn't included. But we do need to add some more in. AI controller, I believe, is one. Navigation system. And I think it's... Oh, I can't remember what the task one is. However, there's a way we can look at these within the editor. So open up your editor. And then it's Windows. Where is it? Development tools. Am I just blind? No, something like up there. They must have moved it with... well, there's a console command. Let me just copy this over. Okay, it's just module list, so... module list. And I believe that puts it into the output log, which it does. Okay, that's what I was trying to get. So these are all... Let me just get back to where that list started, because there's a lot of stuff in here that's getting dumped from startup. Log. Okay, so here we go. So you can see currently there is 519 known modules within the Unreal Editor, and you can see loaded, yes, no. These are the modules that are used for the editor, not for C++. And that's the thing, like, so, where's the AI controller, I believe? AI module, sorry, that's the one there. So these names here should relate. So I'm going to copy AI module. I think I typed that out. Yeah, I put AI controller. We're going to throw that in. Then we have our navigation system and behavior. Where is it? Behavior tree editor. It was a task, I believe. Behavior tree, blueprint graph, bridge. Well, I'm going to find that as well, but MN navigation system. Copy that just to make sure it's right. Now, I'm not saying 100% that these are the exact names that they should be in here. I'm saying these are the names that I would suggest trying with. You can find them. Let me pull this over. Also within the documentation online. So in here, we're looking at our AI controller class. And go down here into your reference. You can see it's got the include, it's got the header file path, but it also has the module. And this is the module name. You can click on that, and it covers various different things and all these classes. And that is something you need to include here in your build file to get the required code access that you need. So with that though, before we get started and start writing code, I've gone through and I've got these two. Can we have a find option in here? I don't think we do. I am actually going to do this because I want to be able to figure this out myself without having to constantly pull this up. So I'm going to copy this. Notepad++. You're not going to let me type. Apparently not, but there it is. I'll paste that in there. Alright, so got this list here. Let's just go task. Find all in current document. Gameplay task editor. No. Okay, let's try Blackboard. Is that in here anywhere? Okay, so that's not showing up in there. Let's move that out of the way. Let's move this back over to my other screen. Actually, no, we need the content browser. So what we're going to do here is we're going to start with a few base classes. So we're going to open up our base class, and I want to start with what's going to be our default NPC class. So what we're going to do is we are going to find our TF character class. We're going to right click and create a C++ class derived from that. TF NPC character. We're going to create that class. Now I am running through Visual Studio, so we are going to do a couple of other bits before we hop back into the code. So we're going to ignore the reload message to start with. And apparently it does not want to let me switch back to the editor yet. There we go. So anyways, just with that, I know I will have mentioned in the intermission that came out before this, I'm going to be doing a slight change up to the way I do my videos. I've just found that my 30-minute videos do better than the hour-plus videos. So I'm going to be trying to keep to that 30-minute mark. It's just going to mean there's a lot more videos out there. And that shouldn't affect my... Actually, if anything, it shouldn't increase the volume of videos. Because instead of doing 3 one-hour videos a week, I should be doing 6-ish 30-minute videos a week. So apparently there's a reason videos are only 30 minutes on YouTube normally, other than your long plays, which are like 3, 4, 5 hours. So yeah. So okay, this is taking a while. So I'm going to pause the video, wait for all of this to get completed, and we'll be back when we add the next class that we want to add in. Alright, so that class got added in, and now we want to add in a controller. Now, we could leave this in base class, but I actually want to add that into a different folder just for ease. So what we're going to do here, right click, new class, all classes, AI controller. I'm going to select that, and so you've got actor, controller, AI controller. Actually, let's just go through. And you can see you also have player controller as well, but we're going to start with the AI controller. And TF AI controller base. And we're going to add that to a controllers folder. And this is just, again, your folder structure is going to be entirely up to yourself, or your project, I should say. These folder structures are how I personally prefer to do it, just simply because I like to have certain distinctions. So things like the base classes are things that are in the world, or that can be placed in the world. Like I said, we're ignoring this for now. Won't let me do anything. And then we also have things like our components, which are things that are added to other actors. We have our data types, our function library, things like that. And the whole purpose for that is just personal preference. So that is going to be down to how you want your project to be organized. Anyways, just like last time, I'm going to pause the video and I'll be back once this is done setting up. Or I say that and it finishes. So the other thing I want to do is I want to also... actually, no, that'll work for this video. So now that we've done that, let's move this back over to the other side. We've got our basic setup here, and we're going to close out the editor to start with. Wait for this to finish. And it's not going to stop debugging. So I'm going to pause the video and I'll be back once this is all ready. All right, so we are back in the editor. Now, the first thing I want to do before we write any code is I want to make sure these modules are the correct ones. So the other one, actually, it was gameplay tasks, I think, or was it task? Let me just look at my notes here. Tasks. Okay, so now that we've added these three, so just to quickly cover, the AI module is for our AI controller. The navigation system is that so we can work with nav mesh, things like that. And the gameplay tasks is so we can start creating behavior tree tasks within C++. So now that we've got those three added in, I'm going to run a build and we're going to make sure this goes through fine. Now again, these could take a little while, so I'm going to pause the video hopefully here in a second, and I will be back once the build's done. Oh, nope, it went through fine. All the linkers worked. Linker. Okay, so those modules worked out. Those are the ones we needed. So now that we've got that added in, first thing we're going to do is controllers. It didn't open those up. Let's get rid of some of these other files I don't need open anymore. And let's get our AI controller open as well. So there is going to be a few things you want to add into your base. And this is going to be following the same class structure I've used before. There is going to be a AI controller for like this AI controller base. And then if we need unique controllers, we do a derived class. So things I'm just giving examples off the top of my head. I don't know if we're going to be adding them in. You would have, say, a wild animal controller. You would have a zombie controller. You would have a raider for a human raider controller. Because they're going to have similar functionalities that we would put in the AI controller base. But then you would have the unique overrides within your individual one, like your wild animal, or you'd have like your bear AI controller base, your deer AI controller base, things like that. And that's going to be down to, again, your project, how deep you want to go down that path, or how far down that path you want to go. And then you have your NPC character, and right now this is just a derived class, and the whole purpose for this is we want to add any NPC specific logic here instead of in the, can't find my own order, the character base class, because this is code that is going to be shared between both the player character and all NPCs. And then you have your NPC character, which is additional code or different additional override logic that we're doing for NPCs. So some of the first things that we want to do here is within the NPC character, because that's where we're going to start. So private, protected, public. And this is just, again, using my personal preference on the formatting. So we want to add a constructor. Well, we're going to do that here. that down in the public section. Thank you, IntelliSense. We need to have our... do we need to override our tick? I don't think we do. Don't need to override our begin play right now. Again, these are things you can, like, you may not think you need to do them now, like override the tick function, override the begin play function. But if you need to do that later on, you can. So, I'm trying to think, what else do we need? Actually, well, let's take a look. Let's take a look at our character base. I'm going to actually open up the header for that. So what we've got in here: stat line, inventory, save actor ID, if it was spawned, our movement logic. We got our tick, set up the input, which we're not worried about. Yeah, no, I don't think there's anything we need to override in there right now. So we're good with that. Let's actually create this definition quickly so it stops complaining. Now, the first thing we're going to want to actually add that is a potential override is going to be a reference to a behavior tree. So let's go, no, we want this protected. So U property, edit a default only. Blueprint, read write. Category. Yeah, I'll just put it into AI. I'm trying to think if there's anything else we need on that. Probably a private access, actually. Meta equals allow private access equals true. And this is a U behavior tree. Well, you see it's not coming up. Well, the reason being there is we need our include. So this one, it is a include behavior tree / no. It's a subfolder, so why is it not giving me that? Include. Sorry, I have notes on this off to the side. Include behavior tree. It should be that. Am I spelling that wrong? BEHABIOR. No, that's right. Well, let's, okay. I'm trying to think of a name. I don't want to just call it BT behavior. Why is that not working? So is that... That's failed because... Okay, well, let's just do that. It still failed. Okay, so let's comment this out and see if that builds, because if it's building, then our include is correct, and I think that's where the issue is the include, because for some reason it wasn't giving me that. All right, well, I'm going to pause. I'm going to let this build run through. Oh no, it's all but done. Okay, that worked. So okay, so this is something that you may find comes up. So let's take a look at the code. So it's just their behavior tree. Come on. Yeah, right there. AI module include behavior tree, behavior tree. I'm just going to copy that. I'm going to throw it directly underneath. We'll do a compare it line by line. Yeah, it's identical. So you may run into an issue like this when you're working with Unreal Engine and C++. I've seen this come up every now and again, and it happens when you make changes here and you don't restart Visual Studio. For some reason, IntelliSense and everything, it doesn't do this linking properly. So I'm going to pause the video, I'm going to shut down and restart Visual Studio, and we'll see if that fixes the problem. Alright, so I have restarted Visual Studio, so let's just take a quick look. Apparently it's not finding that. However, I did also notice my spelling is my error. I have a U in behavior. Fixes the problem. So let's just do a quick test build to make sure. And with that, this is sort of getting towards where the end of where I want to end off this first episode, but I'll let this build while I talk about a few other things. Now, we are, like I said, going to be moving into the AI with the next, I don't know, it's probably going to be 10, 20 episodes. I don't know how long that's going to be. I have none of this planned out. Okay, so that's working. But going from here, each episode is going to try and cover a portion, be it like a task, or these first few episodes are going to be getting the basic things set up, stuff like that. So now that we've got this built and we realize, well, I realize my problem is my spelling. Let's fix it there as well. Behavior. Well, actually just call this behavior tree. So we're going to add in a couple more things before we end this episode off. So one of the first things we're going to want to do though here is we are going to need a way to provide this behavior tree to our AI controllers. So we're going to want to add a getter for it. And this is where, like with some of the other classes, we have had variables that we have made like public protected. And the reason this is protected, not private, is for any class we derive from this, we still want it to be able to modify and update the behavior tree. So we're going to want to add a getter. So U function, blueprint callable, blueprint pure, and then it's going to be a U behavior tree pointer get behavior tree, and this is also going to be a const because we don't want whatever's calling this to be able to modify the behavior tree. So quick action, create the definition there, return behavior tree. As simple as that. Now, one second here, sorry. Didn't want to cough in your guys' ear there. So we've got this set up, and this is really the basics of the behavior tree, the NPC character. We have all of our logic already in our character base that we need right now. From there, we can go through and do logic based on all of this. So the next thing we're going to want to work on is our controller base. And for those who don't know, the AI controller is, I don't want to say the brains of your NPCs, but it's where a lot of logic and functionality is executed to cause it to do things. And then your behavior tree is it deciding what it wants to do. And your behavior trees and your AI controllers are going to talk to each other a lot through various different things like tasks and setting things and stuff like that. So I'm going to start work on our AI controller. So in here, first things first, we're going to do like I do with every class, private, protected, and public. And we're going to set up a controller, constructor for this. So now with that, we need to actually add some things to this. So it's going to be the F object initializer. And this is a constant reference and object initializer. And to explain and why I know this needs to be added, you just go to your AI controller, go to definition, and in here you can go through and I'm going to do a control F, put the open bracket on the end, current document, and find that. And in here we're overriding this. So it's a const, I got that backwards. I make notes of what I need to do, and I wrote this down, write it as a F object initializer constant when it should be a const F object initializer reference. And we are going to create that definition. That is setting up the basic constructor, which is what you need for your AI controller. Now, with that, there is going to be some additional things we want to add to our header file. I just wanted to get this constructor set up first. The next thing we're going to want to add is our onPossessed. And this is where the AI controller sort of takes over a pawn. So this is a virtual void on possess. Single S, double S, possess. It takes a pawn reference, pointer, and this is going to be an override. And again, same thing as before. If you want to check on that, you want to copy your onPossessed, go into your, that opening, here it is, and just do a quick find. And you can see this is already an override, but we're overriding an override. Not a problem there. So close out of that. We're going to go back into our controller base, and we're going to create that definition. I'm trying to think. Let's take a look here. Is there anything else we need to add? All right. So looking at my notes, we don't need to do anything with the constructor, but it's all going to be in the onPossessed. So first thing you're going to do, as with most of our overrides, we want to make sure we use super on onPossess and just go in pawn. And the reason being is this allows any downstream logic within the class. So that's going back here. That's any logic within the AI controller that needs to execute is executed. We had that issue with a couple of our other classes we had created in the past where we weren't calling super and it caused some weird behavior. So that is the very first thing we need to do. The next thing we need to do is we actually want to have a reference to our NPC character base. So I'm going to grab this include here. We're going to throw that in our AI controller base header file, and we're going to put a private reference to that. So save me screwing up my spelling again. We're going to copy this over. Controlled pawn. Now we're going to start off by making that a null pointer. Just it's not going to let me use it. No, is it? Yep. And yeah, we're just going to leave that. We don't need a U property as far as my understanding is. I may have to change that again. So in here, as part of onPossessed, we are going to go if pointer NPC equals cast in pawn. So what this is doing here is basically we're saying if this is successful, we have, I don't like that, it's creating a variable. let's see if actually owning. What? Really? Controlled pawn. Sorry, not owning pawn. Controlled pawn. Okay, so if we have gone through and we can cast this and we've assigned our controlled pawn, we're going to be able to execute some additional logic. And this is what we want, because we want all of this to only happen if we are using using this on a NPC that derives from our NPC character. And I just realized I probably should have called this NPC character base. That is my mistake. However, I'm not going to go through and rename all of that. That gets a little complicated. So now that we have that logic, we need to look at our behavior tree and see, well, is that set up? So what we're going to do here is if behavior tree pointer const no, I read my notes. Const u behavior tree equals, and what did we call that function? Get behavior tree. So we're just going to copy that. Equals controlled pawn get behavior tree. Okay, so that means we've actually pulled a behavior tree out. That means the NPC has one assigned, which is again something like if it doesn't have a behavior tree, well, we're not going to be able to control it. So actually what I'm going to do here is add in an else. And this is where we're going to pull up and use our logger. So I'm just going to get that include. Add that in here. Logger, get instance, add message. No valid behavior, spell that right, tree found. And this is error level. That is going to be a critical error. And the reason for that is basically if you've got NPCs you've set up and you have made a mistake somewhere and you forgot to throw a behavior tree on there for them and things don't work, you want to be able to figure out why. And that's what this is for. Basically any error level logging, I'm going to be, well, any errors you've seen with the other episodes, if you watch them, I throw log errors. So now that we've got that set up and we have been able to find a behavior tree, we need to actually start working with it. So there is a few different things that can be done there. Blackboards are the main thing that drive that drive behavior trees. And for those who don't understand, and I may be describing this incorrectly, but a blackboard is basically the memory of the AI. It's where information is stored, and it's used to be able to frequently update and make changes to that stored information. So what we want to do here is a U Blackboard component reference. We're going to just call that BB for Blackboard. I'm going to use Blackboard. Use Blackboard. And this is going to be from our behavior tree. We want to Blackboard asset. And that's if it has one. And if it doesn't, it's going to create one. If it's got a Blackboard asset, pull it out of the behavior tree and assign it to this BB reference. If it doesn't have a Blackboard, it's actually going to create one. Now that can run into some problems because those are created without variables. So that is something we may have to deal with later in the series. Blackboard equals BB. And then we want to run behavior tree. And I missed my capitalization. What is that not liking? Const. Oh. Why did I have const in my notes? I'm not sure. I had const in my notes for this. So this is the very basics of setting up the behavior tree for your AI. And again, this is very, very simple. A lot of your logic is going to be defined by the behavior tree itself. And that's where things can get very complex or very simple depending on what you are trying to accomplish. But the basics here, we have our behavior tree. So what we're doing here, just to explain, because this is sort of the core elements here, is as soon as the game starts, our AI controller is going to try and possess the pawn. So the AI controller can go, okay, do this. So we're going to try and get the pawn, and we want to make sure that it's one of our derived classes that we've created, so we know that all of, well, actually, not this logic, but we can access all of this functionality. It's all there. That's why we have this cast here. And we're setting a reference to it just because then the AI controller has a reference. We don't need to get owner, things like that, because you do have the option for get the owner, which returns an A actor, which you have to cast. But because we know within our AI controller, we're going to need to access a lot of this functionality on a somewhat frequent basis, it is much easier to have this permanent reference. It's a pointer, so the memory consumption is going to be minimal. Not something I'm concerned about. Now, if you're doing a game like, say, World War Z, the game there, where you had hordes and hordes and hordes of AI, this would not be efficient, because this volume is going to be insane, and I honestly don't actually know how they set that up with that number. I'd actually love to look into that. But anyway, so now we've got that set up. Let's finish going through this. So we've got our reference to our pawn, and then we're going to try and get an assigned behavior tree, which we have assigned here. Well, we have here. And if we've got that behavior tree, we're going to execute some other logic. If we don't, we are going to log an error. And then once we know we have that behavior tree, we're going to grab our Blackboard. Well, create a Blackboard reference. We're going to try and find the Blackboard that is assigned to the behavior tree. If it doesn't have a Blackboard assigned, we're going to actually create one. We store this as the local reference to the Blackboard within the controller, and this is just so that we don't have to. Actually, I think I'm gonna. Yeah, it's not gonna like that Blackboard component. Yeah, it's a T-object pointer. That's why. The soft pointer there for the T-object pointer can't be passed in here. That was the reason why I had done this. We store that as a local reference so that the AI controller can then modify the Blackboard if we need to. And then we're going to say run the behavior tree. So that is the very basics of setting up a simple AI controller. So I'm actually going to end this episode here. Again, shorter episodes for the foreseeable future. I will obviously, as I've been doing, sort of join them all together and make a long play. So as always, though, folks, thanks for watching. If you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. And I will see you on the next episode. So just a quick addendum here. Downside of me recording multiple episodes, I'm sort of not doing my normal builds per episode. I want to throw this quickly in here, just as an addendum. This right here is actually incorrect. We can't do this assignment. So what we need to do here is, I'm going to copy that out, put this down here, and we're going to go and create a pointer to our class called NPC like I had done, and we're going to save that. And as you can see here, is build failed assignment within conditional expression. I don't know why I did that. I was sort of not half-heartedly, my brain was saying do some refactoring as we're going, and sometimes I will do that. I'll try and be more efficient because I didn't want to create this, and there you go, you can see the build work this time. And with that, I had done this, and actually no, I can just do the assignment there. That sort of thing happens. You're going to make those mistakes. Don't feel bad about it. So last episode we went through and we set up the basics for an NPC. In this case, it's a very basic setup where we have our NPC character class and our AI controller that we've defined. Now, as we had mentioned, they use behavior trees and blackboards to decide their logic, store the information to use with that logic, and execute actions. So we need to set up a behavior tree and a blackboard. So I'm going to hop into our content browser here. It's over. I'm in the content section of our project. We have blueprints, our main folder here. We're going to right click new folder. I'm going to go AI. I hate that because it's not going to rename now. Yeah. So it's one issue I found with the editor is you can't fix your capitalizations. You have to change the name and then re-change the name. But anyway, so go into AI. We're going to create a folder, behavior trees, and I'm going to make that with the right spelling. And we're going to go into here, right click, artificial intelligence and behavior tree, BT random Rome. We're going to save that, and then we're going to new folder, and I'm going to do blackboards. And this is just a subfolder. And again, folder organization is going to be down to how you want to do it. You don't have to follow my folder organization. It may not make sense to you. This is how it makes sense to me, though. So in there, we're going to right click. Go into our blackboards folder, artificial intelligence and blackboard. So this is going to be BB random Rome. And we're going to save that. Now, within the blackboard, for what we're doing, we're just going to set up a very basic AI to start with. AI logic can get really complex or really simple depending on what you're wanting. What I want to set up, at least with this first basic one, is going to be something like a deer or another wild animal that's going to wander around. So within here, random Rome, we are just going to need one key. So in the left, we're going to click new key, and we want a vector because that's the location that our AI is going to move to. And move to location. Set that to a very clear name. Now we're going to go back to our behavior tree. We're going to open that up, and you can see it's actually already selected that. Now I don't know how they have that coded. I don't know if it's just based on the first one that it can find, or if it's based on the naming convention. I may have to look into that. But if you find this behavior tree isn't the one you want, you just select it blackboard, and you select the one you want. In this case, I think it might just because it's the only one. Now, to explain a little bit about behavior trees, and don't worry, we're going to get into some code in this episode, but behavior trees all start with this root. Now, the root is where everything comes in. You'll notice you're only allowed one child from a root. And the reason being is this is literally the doorway into the behavior tree. That's all this root node is. It doesn't have advanced logic or anything like that. You can see here, there's nothing set up. So off the root, you can have a selector, a sequence, or a simple parallel. A selector, the way this works is it's going to, I'm just going to grab some tasks here. They're all going to be weights for the purpose of this description. The way a selector works is it is going to execute the tasks in order, and the first one that does not fail is going to be the behavior that's run. So it's going to go from here, it's going to select this one, and you can see it's got little numbers on them, 0, 1, 2, 3. It's the order of operations that the behavior tree runs through. It goes top to bottom, left to right. So the way the selector will work is it's going to go, okay, does this node fail? Okay, it failed. Let's check this node. Did this one fail? No, it didn't. Okay, we're going to execute this logic. Or if this one fails, then it's going to go, okay, did this work? Okay, this worked, we're going to execute this logic. And that's how a selector works. It picks the first one that doesn't fail. Then you have your sequence node, which is actually the one we're going to be using in this example, where it follows an order of operations. It's going to do task 1, then it's going to do task 2, and then it's going to do task 3. And then finally, I'm not 100% sure on the simple parallel. I believe it does this, and then it does a sort of side logic on this off to one side. And I can't remember the order that they take priority, because this is where my understanding is a simple parallel would be used for something like, oh, you've seen something, I want to run away. So that is something we'll be looking into later in the series. But for the time being, we're going to just set up a basic one to make sure we can getting our AI working. Because there is some slight differences I want to do with regards to the nav mesh when we come down to that. So we are going to drag this down. We're going to set a sequence. And what we want this AI to do to start with is basically find a place nearby, move to it, and then hang around for a few seconds. So, well, we don't have a find point. However, we do have a move to, so we're going to put that here. We do have a wait. Now, the wait, it's a variable. You can say wait for dedicated 5 seconds, and you can add a random deviation. So that's going to be a plus or minus, and I'm just going to add a 2 second on there. Move to, we want to use the Blackboard key move to location, because that's obviously the vector that we need to pass in. I'm going to save this. Now, we need a task to find the point to move to. So you could click new task, and this is going to create a blueprint task. Obviously, this is C++ series, and myself, I prefer to write C++ over blueprints wherever possible, just simply because code makes more sense to me than blueprints. I don't like the spaghetti mess that blueprints have. So we're not going to do that. So as I said, I saved this just to make sure this is saved, because we want to add in this find location node. So what we're going to do there, we're going to go to our C++, we're going to go into our public folder, right click, new class. So in here, we have some basic ones, but obviously there is no task in here. It's not something they expect you to add by default. So you need to go to all classes, and we're going to search task. Now you can see there is quite a few things in here that come up. And your first instinct is probably going to go, oh, BT task node, that's what we need. The problem being is that's actually one step too far back. We need the Blackboard based one, because we're using information from a Blackboard. So BT task Blackboard base. BT task blueprint base, but that is the class that is used for the blueprint tasks that you create. We want this one here, BT task Blackboard base. Next. Now in here, we're just going to name that. So I'm going to call this TF BT task. I'm going to actually call it BTT random point in radius. And we're going to create that class. Now I had run the editor from Visual Studio, as this is all being done in one recording session. So we have this reload, and we've made sure everything is saved. So I'm just going to hit reload and do you want to stop debugging? Yes. All right, so now we're back in the editor. We can start adding a few things in here. So the first thing we're going to want to add is obviously a constructor. So we're going to just copy the class name, and this needs to be, actually first thing I'm going to do is set up my sections. So the constructor is going to be a public, and this takes in a F object initializer, and that is a reference to the object initializer. And the reason for this is we have, go to definition, trying to figure out where it is. It's back in task mode, I believe. There is a reason for that, and I didn't actually note that down so it could cover it, which is somewhat annoying on my part, because I do like to explain why. However, we do have, right here is one of the other functions we're going to need to override. This one here, the node result execute task. So I'm actually going to copy that here, because we need that. And this is an override. And then finally, I want to add in a variable that we can edit within the task itself. So we're going to do uProperty here, just so it's exposed to the editor. Edit anywhere. Blueprint read write. Meta equals allow private access equals true. Float search rate, not floor, float search radius. And I'm going to set that to 2500. So with that, let's just quickly create these definitions here. So this here, the execute task, is the primary one that we're looking at. This is going to be where the logic is defined. So in here, we need to go through and make sure I'm trying to think. Brain's not working. 1 second here. All right, so I took a quick look over my notes just to make sure I had everything correct here. So the execute task, this is a function that is used to determine whether or not it succeeded or failed. And so that's things like with the sequence node, or sorry, not the sequence node, the selector. This is where you would define that process. So this is also where we're actually going to be doing all of our logic. The execute task is basically, okay, do your task and then tell me whether you've succeeded or failed. So this is where we're going to be putting the majority of the logic in here. So what we're going to want to do here, though, is we need to reference, or call back, I should say, to our controller to start with. So we're going to go if, what did we call our AI controller? Grab it here. It's going to be, oh, we're missing the include for that. Equals, cast that to, no, to our controller. But what we're casting here is the, apparently I have a noisy truck going past, the owning component, and we need to get AI We're missing a reference for that as well, aren't we? On component, get AI owner. Oh, no, it's not a pointer. Sorry, that's half my issue here. Get AI owner. Yeah, it was. It's just because I was thinking it was a pointer. I'm missing a brace, that's why. So what we're doing here is if we can get back to our AI controller, which is our AI base in this case, we then need to find out where that is. So f vector curlock for current location equals con dot no, we need to also go back to it as a pawn. Pawn? Yeah, pawn will give us get location. So the next thing we want is if a pawn pointer npc equals cast no, we don't need that. That's con.getPawn. Sorry, I've got notes on this because, as I've mentioned in the last couple episodes, I'm trying to reduce the length of these, just because video performance has been better on the 30-minute episodes versus the 45-hour-long ones. So I've got notes to try and cover everything, and I'm getting used to that. So, okay, now that we've got that, it's an f vector curlock equals npc get actor location. Yeah, so that is where it currently is. Now, this is where we're going to go back and reference the build this one here, the navigation system. We need to find a point within the navigable radius. So we need to include that here. Include navigation system. Because that is going to give us access to things like your nav mesh and finding points within that and leveraging all the existing logic. Now, if you're doing some advanced like AI system that's not using the built-in nav mesh, first of all, kudos to you. I looked into doing that and I realized that was more work than I wanted to do. But also, this process isn't going to work. So the next thing, though, we do need to reference that nav system. So if navigation system, what is that? Is it navigation system? It's a U navigation system. That's why U navigation system. V1. So if U navigation V1 pointer, navsys for short form there, equals U navigation system V1 get current, and then it's, well, you think get world. So, because that obviously uses the current world context. So now that we have that, we need to also look at doing some additional work there to set a new location. So we want f vector new lock. And now we're not assigning anything here because the navigation system actually has a find a random point within navigable radius. It's just not a task. So what we're going to do now is if navsys get random point, and then this is where get random reachable point, get random point in navigable, and just get random point. So get random point is going to give you a random location. Get random point in navigable radius is going to find finds a random point in the navigable space restricted to the radius around the origin. Resulting location is not tested for reachability. And then you have pretty much the exact same thing, but it makes sure the AI can reach it. So that's where you're going to see, with some AI, it's going to go off and it's going to like bump into a wall and just keep trying to walk because it doesn't test. Can we actually get a path there? We want the reachable point in radius. So in there, it takes a vector origin. Well, we have that curlock for current location. We have the... Oh, that's where I screwed up. It's an fnav location, not an f vector. Fnav location, new lock. So we want to pass in new lock there. And then we have, oh, sorry, it's radius and then that. So we want search radius new lock. Now there is some additional ones in here. You've got navigation data, things like that, but they're not required. So we're going to do that. Now this only returns true or false. It returns true if any location was found, otherwise false. So what we're doing here is we're basically creating a nested set of pass-fail checks. And from those, we're going to be going through and assigning that. So, well, now that we've got this here where we've done that, so now what we need to do is owner component get blackboard, get blackboard component, and then we're going to be set. Do I not have blackboard? Oh, I didn't add the include for the blackboard component. So include blackboard oh, where is it included? Bear with me 1 second. I'm going to find that include. All right. Was really, I don't know why I was thinking. It's in the behavior tree. Blackboard component. So anyway, so it's owner comp dot, because it's not a pointer, it's a reference, get blackboard component. And then now that we have that in there, we should be able to set value as vector. Set value as vector. And then this is where you can define a name, but we have get selected blackboard key. And this is where, like within that move to, we could assign within the details panel on the right. That's what this is. It's get the selected blackboard key. It's using the one that's defined within the UI. So we don't have to provide a dedicated name. So if we have, and in that way we can use different blackboards with this function, and they don't all have to have the same name. Useful to use that for consistency, but you don't have to do it because of that. And then all we're going to do here is new lock location. Now this is where, as I was mentioning, this is basically, it's a series of pass-fail checks. So, okay, did we, I'll clean this up, I don't need that white space line. Did we correctly cast to our AI controller base? No? Okay, so we failed. We're going to be fixing that in a second. Did we correctly cast to the pawn? No, we failed, so that's going to drop through here. Get rid of that white space. Actually, what we can do to potentially offer some refactoring, I'm going to put that in there. Just move that down one. So did we correctly cast as a pawn to get its location? Yes, we did. Did we get our navigation system? Yes, we did. Okay, so now that we've got those 2 bits of information, well, we've got technically 3. But this was just so we could get that NPC. And actually, I'm going to think about some possible refactoring here. We could probably get rid of this top if and just do that down here. But either way, So now that we've done that, we now say, okay, we've got our nav system, so we're going to get a current location for our NPC. We're going to set up this nav location variable, and we're going to see, did we get that information? Did we find a point? Yes, we did. Okay, so we're going to set our Blackboard task. Then it's finish latent task. And there's this owner comp behavior tree component. Well, we already have that, so we can pass that in, owner comp. And this enum, which is a EBT node result. There's a couple. There's aborted, fail, in progress, succeeded. Well, in this case, we succeeded. And that's just to tell the, I believe that's for the multi-threading, because AIs run on some threads, separate threads, to say that it finished. But we also need to return that EBT node result succeed. So we're going to copy that, and we're going to return. Because in here, we've done everything we need. Garbage collection will clear this up. We don't need to worry about that. So what we're going to do, though, is I'm going to copy this, and then we've got to do pretty much the same thing here on our fail result. Failed, and I'm just going to copy that for ease. And I'm going to put that in here. So right now, this is the very basics of setting up the find random point. There's one more thing we can do, though, and that's actually provide a user-friendly name in the editor. So node name, in the constructor, again, getting ahead of myself, I'm trying to rush, so I'm going to slow things down a little bit. There is a local parameter for nodes called the node name, and this is how it's presented in the editor. So node name equals random point in reachable radius. With that, we've set up this entire blueprint, behavior tree task for how we need it to behave right now. So I'm going to do a build. I'm going to pause the video while this runs, and I'll be back once this build is finished. Okay, so there was a build error, and this is because I messed up the input parameter on the constructor. However, the build error actually tells you what it is here, so we're going to select that line, scroll over a little bit. So it's either without an input parameter, or it's a constant reference, and I missed that constant. So I'll try that. We're going to run another build, and this should actually happen pretty quick because everything else is built now. So I say that, and now it's going to take a while because it actually succeeded. So I'll pause the video, and we'll be back once this build is finished. All right, so that build finished. And just for clarity, I did add the const within the source file as well. I just did that prior to because I realized I needed to show adding that in. So with that, we have finished off pretty much everything here in getting this random task. So what we're going to do, we're going to launch into the editor, and we're going to set up that blueprint behavior tree before we finish things out in this episode. So things are loading up pretty quick in the editor. As I sit here in silence, doing what I don't want to do. Okay, that loaded just as I was about to find a filler. So we're going to go and open up that behavior tree we created earlier on. Do that quickly off to the side here, just for, no, I don't want blueprints, I want AI. All right, drag that over so we can take a look at that. There we go. So now we've got that here. Let's drag off our node, and you can see random point in radius. Really big task name there. And that is based off of not this, which I thought that's what it was, but it's this here. I believe. There's a random point in reachable. Am I blind and my memory sucks? Yeah, random point and reachable radius. Sorry, I am being a complete fool here. It is using this node name. Now, obviously this is a rather large node name, but it is what it is. So now that we've done that, we can select this node, and you can see we have our search radius and our blackboard key. So we're going to set that to move to location. And that blackboard key is what this is going to return, that get selected blackboard key. So with that, we have set up the basics of our behavior tree. This will do exactly what we want it to do. It's going to find a point that's reachable. It's going to move to that location, and it's going to wait for a random variable from 3 to 7 seconds at that location. So I'm actually going to change that to 1 to 5 seconds. I'm going to change that wait just a little bit. So, and as mentioned, this episode we're going to be setting up the really rudimentary AI just to make sure our task is working. So in our blueprints, I'm going to go into our dev folder, right click, new blueprint class, and this is going to be TF NPC. So we have our TF NPC character. We're going to select that, and I'm just going to call this dev underscore BP roaming AI. And we're going to save that. And I put that as D, not dev, but I'll fix that in a moment here. So we have our basic, so our mesh, actually I'm going to move this. You can let me move, thank you. Where did that move to? That's right there. Let's drag that down a little bit. I really dislike how the editor is so unresponsive sometimes. With that though, we're going to go to our third person folder. This is where I started the series. I threw everything from the third person template in here so it was easy to find. Going to our characters, our mannequins, and we're going to go into the mannequins, not the UE4 mannequin. The reason being is the animation blueprints and everything for the UE4 mannequin isn't set up. It just has control rigs and stuff so that you can backport the animations. We want just the mannequins folder, we want the mesh, and we want Manny. Just because we're going to work, this is the base one that we're using. So go back to our NPC character here, maximize that. We're going to set that as our skeletal mesh, and you'll notice it's up in the air and turned sideways. So we need to rotate it 90 degrees, no, negative 90 degrees, and we need to bring it down a bit. So I'm going to throw on snapping to 10, and change that to left view, and we want that root to be there. Actually, I think it's 96 we want. No, minus 86. I'm just going to leave it minus 90. We can actually confirm that here if we go back to our content browser and look at our blueprint for our player character. Its mesh is minus 90, 270. Okay, and that 270 is the same as minus 90. So let's put that in here. 270 rotates the same way. We'll go back to perspective. Now you can see it's T-posing because there's no animation blueprint. But I want to just point out quickly, we do have a stat line, we do have an inventory, and we have the default character movement component because those are being added as part of the TF character class, which the TF NPC derives from. So animation blueprint is what we want to use, and I believe it's the Manny one. We can just check here because the player character is still using Quinn. Come on, editor, why are you being unresponsive? As you can see, the player character here is still using the Quinn. So it's using the ABP Quinn anim class. We want to use the ABP Manny anim class. So we've got that set up there. Now in here, we have our behavior tree. Well, that's currently none. We want to set that to our random one. And we're going to hit save. Now I'm going to move this out of the way and move the content browser out of the way for a second. Now there's one thing we are currently missing in our test level here, and that's a nav mesh. So right click on that and just type nav, and you're going to get a nav mesh bounds volume. That's the one you want to start with. This is a volume that is going to be used to generate your nav mesh. Let's just set that top, zoom out a bit, and you can see it's off in a weird place. So let's just zero out its location. Go back to our perspective, and you can see it's now down there. You want to drag this to roughly the middle because you need to scale it to the correct. Oh, actually, apparently I'm having nav mesh visible. So I'm going to hit P, and I'll explain that in a moment. That just gets rid of the visual nav mesh. We're going to, okay, you're extending out the back there. Yeah, that's good. And scale it to the other way. And now we also want to, just to be safe, we actually want to scale this up as well, because we want the nav mesh to include those buildings. So scale this up and then drag it up. So it's about there. Now, if you, as I said, you hit P on your keyboard, that is going to enable the preview of your nav mesh. Now, right now, you can see it's not showing much. For some reason, I think it's because I pulled that up too high. So you can see in here, though, we've got some green within the building. Nav mesh allows stuff to walk, is going to be able to allow characters to get inside, but it's not all the way down here. And the reason being for that, let me find the edge. I have to go all the way down this end. You can see here it's way too high. So what we need to do is just bring that down to just under the bounds there. And you can see it's now, we've got all of these. It's generated nav mesh on the top of these objects here, even though there's no direct path to them. And that's where that reachable aspect of the navigation mesh comes into play. Because these, if we didn't use reachable, it could generate a point on these, and we don't want that. So now one thing you will notice is our doors are blocking the nav mesh. We don't want that. Something we'll have to fix in another episode, though. So we've got that nav mesh in, so let's drop in that AI. So I'm going to go to our dev. I'm going to quickly fix that name. And dev BP roaming AI. Drop that in, and I'm actually going to, there's our player start there. I'm going to put it so we can visually see it. And let's see if this is going to work for us. So launch play. Well, it's not doing anything. Well, what have we done wrong here? So I already know what that is, and this was an intentional one because I've stumbled into this issue a dozen or so times. I'm going to open up our dev AI blueprint, but I'm also going to hop over to code quick because I want to show you what the issue is. So in here, we are specifically looking for the TF AI controller base. Okay. If we type controller, the AI controller class is just AI controller. So we need to change that to the TF controller base, compile, and save that. And let's try this again. Okay, now you can see it's moving. Now, there's no animation for that, but it's because the animation blueprint is off. There's some logic in there we need to fix. But you can see it's now walking around, moving to random locations. So that task we created last episode is functioning. Let's fix that blueprint issue, though, or the animation blueprint issue. I'll rephrase that. So select a character, get rid of this. We're going to just open that up by selecting the Finding Content browser. And I'm going to open that up so we can actually start working on it. And right now, I can tell you the issue is, let's see, so TF player character. Yeah, okay, so we're casting to a player character. We're getting the movement component. Okay, so is the character valid? Well, this is going to fail because it's not a player character. So what we want to do here is cast to TF character, because all of this logic that we're dealing with is available to a TF character, not a player character. I'm going to delete this, and we're going to find the reference character, and this is TF character. Object reference, do you want to change that? Yes. It's going to throw up this window because it's going to search through and find any place that this could cause problems. We've got a get, a set, and a get. Okay, well, that's not an issue. I'm going to close that out, actually. Bring up this cast. We're going to throw that in here, connect, and assign that value there. We'll just hit compile. Well, now we've got an error. Lean amount isn't something that's exposed to the player, to the TF character. So, and this is the reason why I'm working through this the way I'm doing it. I'm intentionally leaving mistakes in because you're going to have these sort of mistakes as you go through. So, what do we do to fix this? We have two options. Because NPCs can lean, we could move, like if say you're having a raider NPC, you want to have your AI go up to a corner, lean around and take a look, which is something I want to do if I can get my AI working that way. What you can do there is you can just move that lean from the player character to your character base. So if we look at the player character, we have, our lean amount, which is a private variable that we have exposed. And all you have to do there is, in this case, we want to change that from a private variable in the player character to a protected variable on the character base, so the TF character class. So we're just going to look at our protected section and drop that in there. And the reason being is protected for anyone who's not 100% up to speed with C++, because I understand there's, from comments and things, there's people who aren't experienced C++ developers. Protected is a area that this class and any class that derives from it can access. So what we're going to do here, I'm just going to save this blueprint or animation blueprint. We're going to close out of this, close out of the editor. I'd actually launched that. We want to save those. I'd actually launched it from the Epic launcher because I wanted to be a little more responsive than running through the editor. So what we do now is literally we just do a build. And from there, we will be back into the editor once this build is finished and I've launched into things. All right, so that build's completed and we're back in the editor. So we're going to open up that animation blueprint again and we're going to take a look to see. This should have fixed our problem. So all right, so you can see character, which is still, it's saying an unknown class, but it's TF character. And we're pulling lean amount. So we're going to compile and save that there. Now, this isn't going to fix our problem, because this is the, actually, no, that might. But right here, this is looking at movement component, get current acceleration, if the ground speed, however that's set up. So let's just take a look, actually, before I say that's not going to work. So we're going to launch our play in editor here, and you can see they're still not moving. So let's fix that. So with that, how do we go about fixing this? Well, honestly, as I've said in the past, animations are not my strong suit. I'm not great with the anim BP. I'm going to have to do a lot of learning when it comes to animations. I can say, however, this initial animation BP we're working with here, it's a placeholder. So any work we're doing here is going to be replaced by other anim BPs as we go through. Like, as I mentioned, the intent for this particular AI that we're working on right now is for a deer. Obviously, its animations are going to be completely different. So what we've got here is just a rudimentary setup to make sure things are working. So what I'm going to do, drag this out of the way because we don't need the falling portion right now. And we need to make some changes in here. The problem being is this right here is something that is unique to the player character and taking input from the player controller. Well, we're not, in the AI's case, we're not taking input from the player controller. We're taking input from an AI controller. So what we want, get owning actor. No, is it get owning actor? No, it's controlled pawn. So right click pawn, try get pawn owner. Player controlled. And this right here is player controlled. This is going to be our decider. So what we want is drag off the should move and type in select. And it's going to give you your wildcard selector. We're going to go player controlled is our index to select from. So if it is player controlled, we want to use this whole and statement. Otherwise, we just want to look at our ground speed, because up here you can see where we're setting that. We're getting our movement component, our velocity, and we're determining from that how fast we're moving. So if our ground speed is greater than 0, is what we want to use there. So this should, and it's a little messy. Let's try and clean this up. This is why I don't like working in blueprints, is the spaghetti mess you end up with. And it can be a little awkward to try and set these in positions where they don't die, or don't overlap and become a tangled mess. So what we've done there, to just reiterate, sorry, my brain's going 100 miles an hour right now. We're getting the movement component, getting its current acceleration, which is the player character. That is not something that is applied to AI controllers. There's no acceleration because it's accounting for things like sticks on controllers. So if you're setting this up for like an Xbox or PlayStation, you have your controls that have a degree of movement, and you can have slow, fast, things like that. So that's what this is for. It's to determine how fast the character is increasing their acceleration. And that's not something that's applied to AI. So we have this logic here, which is what we want to bypass, because that is what is failing for the AI to move, or to animate, I should say. It's just seen as standing still. So we have this. If it's controlled by the player, we want to account for the acceleration. If it's not controlled by the player, we just want to look at its ground speed. So if we compile and save that, I'm going to move this out of the way, and now we hit play. You can see our NPC is walking. And actually, I targeted those speeds, the default speed, pretty good. I don't see much in the way of a foot slide. Oop, bumped my mouse there. But as you can see, the NPC is now walking around. So let's move them a little faster, though. So I'm going to close out of the Anim blueprint, and we're going to open up that AI blueprint we created in our dev section. So open that up and pull it over here. So this is just the defaults, because we have no defined functions in here or anything like that. But it's easy enough. We have our little stat line section here in movement. We can go through and set our basics. So I'm going to increase the speed to 250. Compile and save that, and I'm just going to move this out of the way and hit play in editor. So now you can see he is moving a lot faster. And again, it doesn't look like there's any foot slide or anything like that. Oh, I wonder if there's a minimum you can add, because he's not moving much. I'll have to look into that. But you can see they're walking around, and we could follow him around for hours and figure out, well, will he go into the building? Will he not? Things like that. But that is where I want to end this episode, folks. Like I've said, I'm going to try and keep these episodes on the shorter side just because, well, they do better. So next episode, we're actually going to, let me pull up this behavior tree here. We're going to expand on this behavior tree, because right now you can see we have our very basic setup here. We're finding a point in reachable radius, we're moving to it, and then we're going to stand for a random duration. What I want to have is I want to have some logic in place where, it sees another AI, or sorry, it sees another character. And from that, it then decides, okay, do I want to run away? Do I want to ignore it? Things like that. And that, again, like I said, referencing deer. In this case, like if a deer sees, say, a rabbit, it's not going to be too worried about it. But if it sees a wolf, a bear, a human in the wild, they run away. And I want to add that sort of behavior in. What I want to achieve, at least with this first AI NPC that I'm working on, is, as I mentioned before, something akin to a deer or a rabbit. Like a wild animal that as soon as it sees something, it stops what it's doing and it runs away. So what we need to do there is start working on the AI perception components. And what those are is that's the AI's ability to see things, hear things, and subsequently react to those. Now, the way that works within Unreal is you have your AI, which has a perception component. I can't remember if that's the exact name, but basically that allows the AI to say, I can see, I can hear, I can touch. There's multiple different senses you can add in. But counter to that, you need to have the objects that you want them to be able to see, to be able to hear, to have what's called a perception stimuli source. And what that is that's basically saying, okay, this object or this actor or this character can generate a sound that the AI can detect. It can be seen by the AI. So what we need to do there is actually start adding that in. Now, because I want to do this that all NPCs can see all NPCs and potentially respond to them, as well as to the player character, we're actually going to add that to our character, our TF character class. So what we want to do here, I'm going to close out of the editor. I can see I've got some stuff open from last episode still. We need to actually hop over to our TF character base. We're going to start in our header. Now we want to add something that is called a UAI perception stimuli source component. It's a pretty complex name, but we're going to set that up. We're going to go U property, edit defaults only, blueprint read only, because we don't want this being modified at runtime or anything like that. It does not need to be a save game because the base class blueprint, or base blueprint classes, I should say, are going to have that information defined. And then we need the meta, get my fingers in the right place on the keyboard, allow private access equals true. We don't need to really add a tooltip to this, but I will just for the sake of consistency. Tooltip, perception stimuli component for all characters, for the character, sorry. And this is going to be a class UAI perception stimuli source component. It's a pointer, and I'm going to call this stimuli source. Now, on its own, this isn't going to do anything. We need to register it with the perception system. We need to also unregister it with the perception system. So what we're going to do there is actually we're going to add in a private function, void, and this is just because as we go through this series, we're going to be adding more and more stimuli. So things like sight, sound. There's going to be a touch component we're going to add for some of the more smarter AI, things like that. So void setup stimuli source. So we're just going to create that definition. So this is actually something we're going to initially call in the constructor. So setup stimuli source. So what we're going to do here is stimuli source equals create default sub object UAI perception stimuli source component. It's going to throw, because we don't have a header yet, text perception. No. Trying to think of a short name. Stimuli source. We'll just call it stimuli source. Now it's going to complain if we try to do anything because we don't actually have a header for this yet. And these are actually thankfully all included in quite a nice little subfolder. Include perception and perception stimuli source component. Now, what we want to do is make sure, as long as this is created successfully, we need to actually register it with the perception system. So if stimuli source register for sense, and then you can see with that it's prompting for a T subclass of AI sense, no, UAI sense, that was my, sorry, UAI sense. Now in here it's just saying UAI sense, but it's actually got multiple different types. What we want is site to start with, and you're going to see this also throws a error because unknown data, unknown or undefined, and that's because we need to actually include that as well. So include, again, in the perception folder, AI sense, and then you can see there's actually quite a few in here. There is blueprint damage, hearing prediction, sight, team, touch. We're just going to worry about sight for this one, but we're actually, just for purposes, because I do need to go through a description, I'm going to also add in hearing as well. So we have register for sense, and I'm going to copy that down. We're just going to duplicate that and go hearing. Now the next thing, to explain what this is covering actually, sorry. So what this is saying is this particular stimuli source or stimulus generator is able to generate sight stimuli. It is able to generate hearing stimuli. It's able to, and if you went with other ones, you're able to generate touch stimuli, things like that. So what we want to do now is go stimuli, if I could spell stimuli source, we need to register with the perception system. And what this is doing is saying, okay, we have determined we're going to use sight. Oh, sorry, we can generate sight events. We've determined we can generate hearing events. Now we need to say, okay, now start paying attention to me. And the whole reason for this having to be in this order, and this is an important part, is what this is doing is it's pushing back, in simple terms, I don't fully understand the code yet. I've been studying it, but what it's saying is this line here is saying this stimuli source can generate sight events. This stimuli source can generate hearing events. And then we're saying, okay, perception system, which is a background system within the Unreal Engine that's used for AI. This is saying, okay, I'm done with my initial setup. Here we go. I'm an actor that can generate these stimuli. So now there is something else we need to do. We need to unregister with the perception system when the actor is removed. So what we are going to do is I'm just going to quickly grab from the Chrono Manager, because I do know I have an end play in here somewhere. Right there. Going to grab that. We're going to head back over to our TF character because we don't have that defined yet. What did I have? Was that private? Yeah, that was in the private section. So, and we're going to throw that in here right under the setup stimuli source. Now, the reason for this is, as I mentioned, we need to unregister with that. Otherwise, you're going to end up with, let's say you have, I'm going to take a game like, say, the World War Z game, where you have just hordes of zombies. And just imagine each one of those is registered with a stimuli source. As you kill them, you're going to want to unregister them so that that stimuli source list gets smaller instead of being this huge list that isn't needed. So what we're going to do here is, again, very similar to what we did with the setup stimuli source. It's going to be if stimuli source unregister with perception system, or from perception system. And it's as simple as that. It's just basically saying, okay, you don't need to worry about me anymore. I'm done generating site events. I'm done generating sound events, things like that. And then just because we've ran into this before, we want to make sure we call our super end play and pass in the end play reason. And this is just so you can make sure things like garbage collection and everything like that is done correctly. So what we're going to do here is we're going to do a quick build, and we're going to hop into the editor and just make sure everything's still working and that we can at least see the stimuli component that we've added to, well, because we've added it to the TF character class, it should be present on both the NPC we created in the last couple episodes as well as the player character. So I will pause and I'll be back once we're in the editor. All right, folks, so we are back in the editor. So let's just take a quick look at the various blueprints for the the two blueprints for both the NPC and the AI. So blueprints, dev blueprint, roaming AI. So this is something you may notice, and can't remember if I've covered this in previous episodes or not, but when you open up a blueprint, sometimes you're going to find yourself brought to what I like to call the Blueprint Lite editor. And that's this very basic. It's just giving you what would be in the details panel on the right-hand side if you selected the root actor. Or you can have, sometimes you're going to get pulled into the full blueprint editor. And the reason, at least that I've found, is simply right now this blueprint does not have any custom blueprint logic. Everything is still running purely on the C++. So now if we were to add in something off the begin play, it would open up into here right away. And I think that's just Epic's way of trying to keep things simplified. So, but either way, so on here you can see we have a stimuli source. And what we did with the, sorry, let's pull this up quickly, with this register for sense. Just get back into the editor here. That is what effectively this portion is for here. We don't need to actually add anything. Now, if you're doing this purely through blueprints and you went through add AI perception stimuli source, you added it this way. In here is where you would do that registration. You'd click here and go, okay, I want to say I can generate hearing events. I want to generate sight events, touch events, damage events. Some of these I'm not even sure what they're for, like prediction and team. I don't know. I've never dug into them. So, but because we're doing this through C++, we don't need this here. So I'm going to delete that. Let's compile and save to make sure there's no build errors there. Okay. And we're going to open up our third person blueprint. And in here we have that same stimuli source. So that is all set up. You can see it's coming in through from the TF character, variable name stimulus source, editable when inherited. That's from the edit defaults. Component tick. Yep. Now this is one of the other ones that I haven't quite figured out what is going to be the most efficient. but you have the ability to change your tick group. And what that is there is every tick, which is frame within your your game, so every render frame, there's actually 4 separate tick actions that happen. There is the pre-physics, during physics, post-physics, and post-update work. And they follow in that order: pre-physics, during physics, or sorry, it should be pre-physics, physics, post-physics, and after everything else. And those are when its tick logic is going to fire off. Now, this applies to a bunch of different components. So if we go to stat line here, you can see you can change your tick group there. It's entirely outside the scope of this episode, but seeing it, I wanted to talk about it. I have not figured out why. There is going to be a reason. Obviously, it's something that's provided to you. I haven't figured out what would be a good reason to change that. I assume if you have like a very physics-heavy game, you would want to either do it pre-physics or post-physics. But anyways, so that's besides the point. So as you can see here, though, our player character also has that. And again, that's because we added it to the TF character class. So the next thing we need to do is actually make it so our NPC here is able to register those events and respond accordingly. So what we need to do there, don't know why I moved that. I wanted to close that out. We do need to go back into the editor, and we need to, let's get my screen set back up how I like it. We need to now work on your AI controller. So close out of that, and I'll let this finish debugging, and there we go. And we will get started with our AI controller. Where's the header? There it is. Come on. So the work we need to do in the NPC controller is actually, well, it's pretty complex. There's quite a few parts to it. I'm probably going to end up having to split this into 2 parts just with the new sort of 30-minute episodes, but we'll see how much we can cover here. So first and foremost, in the private section, we need to add what is called, that is a class, UAI sense config site. This is a pointer, and we're going to call this site config, and this is probably going to throw an error. Is it not? Well, I know it's going to, so we're going to add that in anyways. Include, oh no, that's a class, so it won't throw an error. We do also, well actually no, we're just going to work on the site for now. So there, with this site configuration, that's how you determine the AI's like field of view, the distance, things like that. So, and the next thing we're going to want, very similar to how we set up the, sorry, we did that in character. We set up the stimuli source. We're going to want a function that's used to purely set up the site configuration. So in here, we're going to add that in underneath. Void setup perception configuration. Now this is, I'm using the perception configuration because this is going to handle things like hearing and everything like that when we start adding that in. So I'm just going to quickly create that definition here. All right, now with that set up, there is at least one more function we're going to need to add into our header here. And this is what, and this is purely for site. So I'll clarify that. What this is it is a function that's called when a site stimulus is registered with the perception. So what we're going to do here is we are going to, no, we'll do that underneath. This one, because it's something that's accessed within backend logic of the engine, you want to make sure it's a U function. It doesn't need any attributes, but it is a void on target detected. and it takes an A actor pointer, and that is the actor, and then FAI stimulus, AI, not AT. Apparently I can't spell. FAI stimulus. I spell that right? FAI stimulus. And that's probably a header that's missing there. Okay, so this is something that you could run across with your own work. You're going to sit here and you're going to find, oh, I need this particular data type. In this case, I'm pretty sure that's a struct. What I normally do is I will go change my find all to the entire solution. You can see it was probably the last thing I did, and just hit find all. And now this is going to return a ton of stuff. First and foremost, we can get rid of this. And then we can just look through and... Okay, so this has the right. We've got... no. Yeah, so this is what we're looking for here. Okay, so AI perception types is what we need. So... And that's what I was trying to explain there. So you find a case where it's got what you need. You right click and go to definition. And then 9 times out of 10, it's going to take you to the header that has that. In this case, it's AI perception types. So include AI perception types. No. That's going to say I can't find it, right? Because it is in perception. AI perception types, I bet. And you can confirm, right click, go to, no. Okay, let's take a look in here. Okay, we'll just add it here and see just quickly. Include perception, AI perception types. Okay, so why is it not letting me do that here? Undo all of that. Oh, now it is. Okay, so that is working fine. So right click, go to, and create that definition. Hey there, folks. So last episode, we started working on getting the AI perception set up, and we ended off with these couple of functions being added in. So we defined the on-target detection and the setup perception. And I spelled that wrong, so I'm going to have to fix that perception configuration. I'm going to fix that in the header as well. Perception configuration. And from there, as I said, we ended off, we needed to expand on that, and there was a lot more to do. So first thing I'm going to do, though, we're going to head back to our source file, and we're going to call this setup perception configuration within the constructor. So, and that's just to make sure, much like we did with the TF character, that it's called on construction. So I'm going to get rid of the on possess. And our minimize that, and we'll minimize the target detection for now as well. So now, as I mentioned, this is going to get pretty complicated, so I'm going to try and work through this as best I can. Obviously, if there's any questions, please feel free to throw them in the comments, hop into Discord and ask there, and I will do my best to help out. AI is not my strongest suit, at least with Unreal Engine, so I do apologize. But so first thing, there is a couple of headers we need to include. So first one is include perception, and then this is AI perception component. We also need to include perception, and this one is we're gonna add to this as we add additional perception types. But it is AI sense config site. So now that we've got that, the next thing we want to do is we actually want to start setting up this perception logic. So what we want to do here, we want to just make sure we get this configuration variable name correct. So I'm just going to copy that. That's because I have horrible typo issues. So we're going to go site config equals create default subobject, very standard approach for Unreal, UAI sense config site. And then just text site configuration. Now, much like we did with the character, it's if site config. We're going to start doing a bunch of other things with that. So this is where it's going to start getting complicated because there's a lot of information here. I'm going to try and cover these as I go through them. So first thing you want to do is set perception component. And for that, we want to create default subobject UAI perception component. And I'm going to name that the perception component. And what this is doing is it's adding a perception component to the controller. You could add this independently, but what's it complaining about? Oh, yeah. Do you not like that? Okay, we do have to add that. So, okay, so we're going to add that to the controller as well. Call this a, what was that again? It is a UAI perception component. That's going to have to be a class. Pointer perception component. All right. So I'm trying to get a little fancy when I should probably keep things basic. So what we're going to do here actually is perception component equals create default subobject UAI perception component text perception component. Now, if this fails, we don't want to do anything else. So if perception component come on, I fixed it. Actually, no, we can do this. I'm going to do this a different way. If not valid perception component, we're going to do like I've done before. We're just going to return. We don't need to execute any additional logic. Our perception component doesn't exist, so the rest of this logic is useless. So we're going to do it that way. Just fix these tab lines, indentations. All right, there we go. Sorry. So this is where we want to now call set perception. No, set perception component, perception component. And I believe that has to be a reference in this case. No, pointer. Okay, so what we're doing here, just to quickly clarify, we are creating a perception component. If that fails, nothing else is going to work. So we want to drop out and actually to do add logged error message. So now we've set perception component. What we're doing here is we're saying, okay, for this controller, use this perception component. Now, this is where you are going to define your configuration options. So, what we actually are going to ultimately end up doing is we're going to set this at something we can modify within the editor. But for now, we're just going to do it all here at a code level. So first things first, site config. And you can see there is a ton of sub options there. What I'm going to do, actually, I'm going to drop back one, copy that, because we're going to be doing this a lot. Site radius equals, I'm going to start with 1,000 just for ease. And then this one is last, no. Oh, what are some of these options in here? Let's see. I sort of wish they grouped these between, like, had some sub-organization, so there's like functions and variables. Auto success range for last seen. Let's see, what else we got? Oh, there's a lot of options, including all the executes. So, is it lose site radius? There we go. That was the one I wanted. Equals, again, we're going to want to set this up to, actually, can we do this? I'm going to add 100 to that. I think that might work. I'm not sure. So now, one of the big ones, as I mentioned, it's their field of view. So site config, I know I got that in my, no, I copy pasted something else. FOV field angle. Let's peripheral vision angle degrees. Is that the right one? I'm going to assume so. So now this is where you're going to have, like, some animals have, say, a 90-degree field of vision, some have 180. For this very basic one, we're just going to go with your default 90. Because though this ultimately is going to be for something like a deer, 90 degrees is sort of a nice cone in front. So what was the other one? Site config, something about age was one of the other ones. Set max age. Okay, so this is how long it will be considered a valid perception object. So in this case, it's how long after I've seen it once do I still count as seeing it. So what we want to do there is, in my case, I wanted something short. I'm going to go for like 2 seconds. Just because what that is that's, okay, so the deer's seen it. Using this deer example, the deer's seen it. It's turning around to run away. Well, I'm going to let it run for 2 seconds, and then it's going to sort of stop. Again, you're going to want to make that a variable. So I'm trying to think what else we need to do here. There's actually quite a few options. So I've got it open up on the side screen here with some of the various different options. So so there is one here, and this is going to be down to your game. So for example, if you have like only 2 or 3, from what I'm going to call for this description, factions. So you have like humans, animals, zombies. I'll use that for an example. You have the ability to set something what's called detect by affiliation. And by default, within Unreal Engine, there's three. There's friendlies, there's neutrals, and there's enemies. However, because of the nature of the game I'm working on, there's going to be far more than three. So it's going to be really hard to, well, I don't want to say factions. There's going to be more than three. Every creature is going to have those three types. However, it's defining them. So I'm actually going to handle that down in the on target detected section. So the next one is going to be, we need to actually now set a few things up now that we've got the configuration, or this basic configuration. And there, as I said, there is a bunch of other things in here. I don't know what they're all for. We may come back and have to edit some stuff in the future as I figure some of this out. So the next thing, though, it is get perception component. Oh, we don't need to get it. We've got it. So perception component. Set domain sense. And that is site config. What? Oh, no, there's a function there. That's why. Get sense implementation, that's why. All right. So now this is where we are going to set this function up. So it's perception component on target perception info updated or updated. Notifies all bound objects that the perception of is updated for a given target. Notification is broadcast for all received. Okay, so yeah, we want just updated. Now this is much like if you're adding an overlap trigger or an overlap event, things like that. It's add dynamic. That's this. And then it's the function, which is a reference to that, I believe. What do you mean? I mean, it doesn't have that. Or maybe that doesn't need to use the get perception component. Yep. No, okay, I'm going to undo that. Okay, just because this error is concerning me a little bit, I'm going to do a build here. I'm going to just make sure this is working, because my understanding of when I look through all of this, all of the notes, is what this is doing is saying, okay, when we are getting a perception update, we're going to call this. So, okay, that failed. Add dynamic. What? Okay, let me just take a look at this again. So, okay, get perception component. And that returns the UAI perception component, which is, we've set that. So on there, then it is on target add, it's right there. Add dynamic. Did I just have a typo? Yeah, I must have had a typo. Wow, I'm having one of those days. Okay, so I'm going to just copy this. Now let's undo all of this, because now that's just frustrating. Oh, yeah, I had a typo. I can't spell dynamic. That's my issue. All right, so now that we've added that, what we've done, sorry, that took me a little longer to figure out than I wanted to. What we've done there is basically like with our sphere colliders on our player character here, where we have let me find it, these overlap events where we're detecting for an interactive actor. Excuse me. What we're doing is we're just saying, okay, when this particular function is called on the AI perception component, pass through the information to this function. So that's what we're doing there. So going back to the AI controller. So what this is saying is, okay, when we have determined we're seeing a new target, call this, we want you to call this function. So that's what that's done there. And all right, now that that part is done, we want to obviously add in some configuration data, I believe. So perception component, configure sense, site config. Okay, and yeah, that needs to be a pointer because the way it's expecting it. So that should be a con. All right, so now that we've done this here, we're only 18 minutes in, we're going to want to start looking at the on target detected. But what I'm going to do here is actually I'm going to if gengine add on screen debug message, key 0, time display, F color red, AI saw something. So what this is this is just a code level presenting that message on screen. We did that with our tree harvest actor. Yes, I'm pretty sure we did. Maybe I got rid of it. Was on harvest. So harvest state. I must have got rid of it in here. But yeah, that's where that's the on-screen debug message at a C++ level. Oh no, I wrote that in blueprints. That's why. So we are going to build this quickly, and we're going to see if there's been any changes to this with our AI. Genuinely, I'm not expecting anything. Like say, I'm still trying to figure all of this out. Yeah. All right, and there we go. So we're going to hop into the editor here. And just while this loads up, what my sort of goals are here is we'll be expanding this on target detected to do things like, okay, is it a TF character? Okay, it's a TF character. What is its AI type or character type? That's a new data type I'm thinking of adding in, and that'll be able to generate effectively a state machine to determine okay, there's something not working with our perception there because the AI is walking straight to us. Okay, what didn't work there? So okay, so we're going to go there. Okay, so that is valid. Site config is valid. Okay. That is working, so I wonder what else I've missed here. Okay. Give me one moment. I'm going to look through some of the notes I took just to see if I've missed something glaring. All right, so looking over my notes, I think it was actually when I started talking about factions and things like that, I think I missed something there. So what we want is in here, it's site config, detection by affiliation dot detect enemies. We want that to be true. And I'm going to copy this part just because detect friendlies equals true. We want it to detect everything. And detect neutrals equals true. Actually, I think I just seen a function that'll do all of that. Detect all flags. No, that's get. Okay, no, these are returns. Okay, so no, we do want to set those that way. So let's give this a shot. So I'm going to close out of the editor here. I'll let this stop debugging. So I'm going to launch another build so this all gets recompiled, and I'll be back in the editor once this is done. All right, so we're back in the editor here, and let's see if that actually fixed my issue. Okay, so we're calling that. We're hitting that. Okay, that's good. Nothing failed there. Maybe I'm missing something. Oh, nope, there we go. Okay, so that was the issue, is we didn't have the site config detect by affiliation set correctly. That was the issue. So as you can see up here in the top left, AI saw something. So okay, so I'm actually going to end this episode here just because the next portion is going to take a bit of time. We need to go through and expand our TF character, create a new data type, and a few other things there. So with that, folks, as always, thank you for watching. If you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Thanks again, and I will see you in the next episode.